Good morning, RC2. Let's say meron tayong column with irregular rebars. Yan. Sabihin nyo na lang na, kunyari, yung top bars, dalawang 20 and 2 10 mm, no? So obviously, yung 10 mm mo, nakadikit siya sa ties. Okay? Ang centroid niyan ngayon is X4. That would be considering the largest diameter. So that would be clear cover plus diameter of ties plus diameter of bar all over 2. Let's say yung clear cover mo ay 40. Okay? Plus 10 plus 20 all over 2. So that would give you 60 mm. And then, meron tayong rebars dito sa gitna. Dalawang 16 tsaka dalawang 12. Pwede yan. As I've said before, kahit ibang sizes niyan, ang assumption natin dyan is equally distributed, ano? So, yung center nito, center ng AS dyan, tsaka yung center ng AS dyan, dito sa ilalim, i-divide mo yan ng tatlo, yun yung centroid ng rebar sa gitna. Next, kung dito naman sa AS1, let's say, isang 25, tapos isang 28, and then dalawang 12. So, ang kanyang centroid manggagaling sa taas. Okay? You have to consider again the largest rebar size. Okay? So, that would be X1 would be equal to H minus clear cover minus diameter of tie minus dB all over 2. Oops, sorry. Okay, so X1 would be, ito na yung X1, ano? H minus clear cover minus diameter of tie minus dB over 2. Ang ating diameter na gagamitin yung largest size, which is 28. But hindi ako magbibigay ng sample na highly irregular ang rebars kasi napakahirap na mag-solve noon. Sa interaction points pa lang, complete tedious nang mag-solve. Okay, so for now, we will limit our rebars to regular shape or symmetrically shaped. Okay? Meaning, yung bakal sa taas, as much as possible, parehas lang ng bakal sa ilalim. Okay? Pero pwede tayong mag-iba ng size dito sa gitna. Let's say dito, dalawang 20, dalawang 10. Ganon din ang ilalagay natin sa ilalim. Dalawang 20, tsaka dalawang 10. Okay? Pero in reality, pwede ka pa rin magpalit ng rebar. Okay, dalawang 20, pwede dito dalawang 12. Okay lang yan. That is, kung sabihin mo na, naubusan ka na ng 10 mm, merong 12 mm. O di, ganyan ang ilalagay mo. Pero pag i-analyze mo, gawin mo na lang na symmetrical sila. Okay? And then, now, why am I saying this? Kasi, kapag i-plot mo yung interaction points niyan, Okay, so this is B and this is H. Okay, so meron tayong curve na interaction points. This is point 1, point 2, point 3, so forth and so on. I think this is point 6. Yan, maximum dyan. Tapos point 7. Tapos ganon. Point 8. And then something like that. This is point 9. Okay? Ganyan siya, ang curve. Let's say regular yung beam. Regular means symmetrical along the h over 2. Okay? Kung gagawin mo yung irregular shape, let's say AS1 is greater than AS2. AS1 is greater than AS4. Okay? For example, this is 2, 25, and 2, 12. Okay, so that is AS1. Yung AS2, no, AS4 naman, 2, 20, and 2, 12. Okay? Magkakaroon sila ng different interaction curves. Okay, so probably magiging unsymmetrical yung kanilang interaction curve. Okay, so pwedeng ganyan, no, yeah. So yung interaction curve para dito pataba siguro, something like this. Pero pag ko-consider mo na yung pagbabaliktarin mo na sila, no? Gagawin mo ng ganito. Chances yung interaction curve mo papayat, something like that. Okay? So kaya ililimit natin yung ating rebars as much as possible symmetrical. And then ganon din sa pag i-rotate mo yung column. Let's say ito na ang gagamitin natin. Kunyari, this is 400, then this is 500. Okay? Kung i-analyze mo yan ngayon, ang gagawin mo riyan, so ito na ngayon yung 500 and then 400. Pag i-analyze mo siya, ito na ang yung H and then this will be your B. Then you repeat the entire process. But notice na yung section mo, it is actually the same section. So magkakaroon na naman to ng sarili niyang interaction curve. Kaya in reality, yung column, 4 ang kanyang interaction curve, no? So yan yung una nating sinolve. Tapos pag palo nung moment sa kabila, negative x, ganyan. Tapos pagpalo nung moment sa y-axis, magkakaroon siya ng interaction curve, ganyan. Okay, so let's say this is mx, then ito naman yung mx negative, then my, tapos my negative. Okay, so kanya-kanyang interaction curve yan. Yung ni-lecture natin is along MX pa lang. Alright? Pero meron akong mga binigay na samples na yung H is greater, yung H is lesser than B. I think may mga samples akong binigay na ganyan or quiz na ganito. Yan yung part na ang sinosolve mo ngayon yung ganitong curve. Okay? So, meron ako mga binigay na quiz where this is B and H. Ano? Your H is obviously greater than B. And then, meron din akong binigay na sample na this is still your B. But then, your your H is lesser than B. You're actually solving one column but solving the interaction curves in two directions. Okay? Ganon. So, ililimit natin yung column natin as much as possible sa symmetrical rebars. Next, guys, is let's summarize yung mga sinabi ko kanina. Unang-una, yung rebars, kapag irregular size like this, 225, 216, ang basis mo ng centroid, yung pinakamalaking diameter. Okay? Ganon din sa ilalim. Pinakamalaking diameter ang i-consider mo na centroid. And then, pwede mong i-rotate yung section mo, pero yung rebars mo, it should be symmetrical in both axes. Kung ano yung bakal mo sa taas, ganun din yung bakal mo sa baba. Kung ano yung bakal mo sa left, ganun din yung bakal mo sa right. And then, yun ang magiging basis ng ating Bresler equation. Let's say we have a section, something like this. Okay, so yan yung column natin. Tapos, ito yung application ng P. Ayan yung PU. Tapos, meron tayong MU at x-axis. Tapos, pag palo ng moment mo, ganyan. Let's say this is MU y-axis. Okay? Notice na sa MUX, yan yung ating inanalyze, ano? MUX. Okay, so MUX, considering that B is less than H. Okay? And then for MUY, ang mangyayari dito niyan, yung B mo ngayon magiging greater than H. Okay? Let's say this is 400, tapos ito naman ay 500. If you are solving MUX, so ang B mo ngayon is 400, tapos ang H mo, yan yung 500. Kapag i-consider mo naman yung MUY, ang B mo, yan yung 500, tapos yung H mo is 400. Okay? So in short, i-rotate mo lang yun. And masosolve mo yung mga interaction points niya. which leads us now to Bresler reciprocal method. Okay, so Bresler reciprocal method. So, ang ibig sabihin yan, so, ang purpose na ito, let's say at some point, yung earthquake pumalo ng ganito. Okay? Yan yung palo ng earthquake. And according to your analysis, okay, meron siyang PU. Obviously, yung PU is isa lang, PU. And then, maglalabas siya ngayon ng MUX tsaka MUY. Okay? So, in short, given yan. Next is, kukunin mo ngayon yung capacity ng section kung safe siya against this given loads. Okay, so may MUX, MUY. This is called now biaxial bending. Meaning, yung column mo, pag ganito ang earthquake, magde-deflect yan. Pag ganyan, magde-deflect din ito. Yan. In both directions. Ganito ang nangyayari sa reality. Always may biaxial bending. So, ang goal natin ngayon is yung demand capacity ratio should be less than 1. Yung demand capacity, that is the ratio PU all over VPN. Wherein yung PU, yan yung load, tapos VPN, yan yung allowable axial load, or ito yung VPU. Pero PN, this is considering now your biaxial bending. It should be less than or equal to 1. So, ibig sabihin, kapag mas mataas na yung load mo, PU, sa allowable, that would be greater than 1. Ibig sabihin, hindi na kaya nung column. Fail na siya. So, as much as possible, yung BC ratio should always be less than 1. Okay? Or equal to 1. Kapag equal to 1, ibig sabihin, PU is equal to VPN. Okay? So, yan. Next, to solve your VPN, dapat makukuha natin yung VPNX. Yan yung allowable in x-axis. Tapos VPNY, allowable in y direction. And then yung PO, nasa first point na yan. Okay? So, we will use the same example to solve for VPNX and VPNY. So, let's continue. Ito yung ating previous example, 400 by 500 with 12 pieces na 20 mm. Ito yung kanyang plot. Okay? So, ayan. Mapapansin nyo kung papalitan ko yung mga rebars, let's say, yung AS4, yan yung bakal dito sa taas, gawin kong 4 na 16. Okay? Mag-iibang kanyang plot. Yan. Tapos, yung AS1 naman, yung bakal dito sa ilalim, gawin kong 4 na 25. Okay? let's say, tatlong 25. Okay, nag-iiba pa rin ang kanyang plot. And then, pwede mo ring palitan yung mga rebars dito sa gitna. Dalawang 10. Okay, see? 416 dito sa taas. Tapos sa gitna, dalawang 10 sa pinakailalim. Apat na 25. Nag-iiba ang kanyang plot. Ano? Kung pagbaliktarin naman natin yan, ito ngayon ang gawin nating apat na 25. Tapos 16 sa ilalim. See? Nag-iiba ang kanyang curve. Yan ang purpose ng interaction curves in positive x, mx, and negative my. Ganon din negative x tsaka negative y. Things like those. Sa apat na axis siya. Pero pagdating na sa Bresler equation, very complicated na yung mga ganito. That's why I've said before na ililimit natin siya sa symmetrical rebars. Okay, so balik natin to sa apat na 20, dalawang 20, tsaka apat na 20 ulit. Next is using the same section. Okay, pag babaliktarin ko na ngayon, yung H ang gagawin kong 400, yung B ang gagawin kong 500. Okay, so nag-iiba ang kanyang interaction points. But we are still using the same flow of equations. Ganyan. So, probably ngayon, gagawa na natin siya ng Bresler interaction points. Ano? So, using the same section, meron tayong PU 982.07. Tapos, moments in both directions, MUX 128.34, then MUY 206.57. Yung MUX, that is moment at x-axis. Okay, so yan yung MUX. Yung MUY naman, moment at y-axis. So, mapapansin nyo na dapat magpe-fail tong beam na ito kasi mapapansin nyo malakas ang moment sa MUY. Pero yung section, it is designed to resist a larger moment at MUX, di ba? Kasi mas mataas ang kanyang moment of inertia. Di ba? So, let's check here. So, ang B natin using this equation would be B is 400. Tapos, yung H is 500. So, dito tayo sa MUX. Notice na yung PU 982, so somewhere here. Tapos, yung kanyang MUX is 128. So, let's say this is your point, no? 982, tapos MUX 128. So, yung point mo, nandito sa loob. Okay? Next, palitan natin yung section, gawin natin 400, tapos 500. So, ang i-consider natin ngayon is yung MUY na 206. So, 206, 1,000, somewhere here. Yung PU, 987. Tapos, yung Y is 206. So, dito na. Nasa loob pa rin. Safe pa rin, ano? pero malapit na siyang lumabas. Okay? Ngayon, i-combine natin yung dalawa using Bresler reciprocal method. Okay, so going back to our same figure, ito siya, yung B is 400 and then H is 500 with 12 pieces na 20 mm. Ang ating PU is 982. Tapos, yung corresponding MUX is 128.34. So, ito ang ating moments. Given na yan. Ito ang kanyang Bresler P sub n. Ito yung sosolving natin. Okay? Tapos, next naman, binaliktad natin yung section. Okay? Dahil MUY naman na tayo. Di-rotate lang. Magiging ganito na siya, no? Ito. Ang kanyang Bresler would be 1143. So this time, ang kanyang MU naging 206. Which is ito. So for now, i-derive natin yung pag-compute ng Bresler PN. Yan. Okay? So let's say this is point 1, point 2, point 3, point 4, point 5, point 6, 7, 8. Okay? So, ulitin ko, this is 1, 2, then point 3, 4, 5, 6, 7, 8. And then, let's say this is range 3. Okay, so that is range 3. Then, this is range 4. Tapos, this is range 5. And then, this is range 6. So forth and so on. Okay. Next is, kukunin natin yung eccentricity. So, eccentricity ng point 3 would be 147.91 all over 3240.13. That is equal to 0.046. Okay? And then, eccentricity ng 4, eccentricity of 4 is 213 divided by 2766, which is 0.077. And then, eccentricity ng 5 is 0.148. Okay, so, yan yung mga eccentricities. E3, 0.046, E4, 0.077, E5, 0.148, E6, 0.239. And then, remember that slope is equal to vertical all over horizontal. Pero, ang ating eccentricity is equal to moment all over P. But, yung moment natin, yan yung x-axis, di ba? Yung x-axis ito. So, this is your phi mn. Tapos, ito naman yung phi pn, okay? So, yung ating slope is actually equal to 1 all over E. Okay? So, your slope now is equal to 1 all over E. So, that is equal to phi pn all over phi mn. Okay? Next, kukunin natin yung actual E. So, yung actual E natin is 128.34 all over 982.07, which is equal to 0.13. So, hahanapin natin ngayon kung nasa ang range si 0.13, ano? So, 0.13 is greater than 0.077 and it is less than 0.14. Okay? So, yung 0.77, ito yon. Okay? Tapos, yung 0.148, which is E5, okay, ito yung 0.148, which is E5, ito yon. So, ang ating E is somewhere here. Okay? Ito yung ating E. So, E is at range 5. So, therefore, use range 5. Okay? Yan. So, this is range 5, this is range 6, range 7. Next is, we will isolate this triangle. So, let's take this as your 0, 4, 5 triangle or your or sabihin natin na range 5 triangle, okay? Range 5 triangle. So, let's take this as 0.4 and then 0.5. Okay. And remember that this is range 5, okay? Tapos, ang coordinates nito, basics, for 0.5, this is VMN 284.96. Okay, ayan, yung 0.5, okay? And then, yung vertical niya, that is 1923.19. Okay, next, let's take this as this is your VMN for 0.5 and then VPN for 0.5. And then punta tayo ngayon sa 0.4. Ang kanyang x-coordinate would be 213.57. Tapos, ang kanyang y is 2766.15. And then we have the E, slope E. Okay. Ito yung ating E defined by angle phi. Also, remember that your eccentricity E is 0.13, which is greater than E4 na 0.077 and less than E5 na 0.01 na 0.148. Okay? So, yan yung reason na nakuha natin yung range. So, from 4 to 0.5 or that is your range 5. Next is, i-convert natin yung ating figure in such a way na magiging applicable siya in any range. Okay? Except dun sa range na 8. So, ito yung kanyang equivalent figure. So yung 0.4, magiging point L, tapos yung 0.5 magiging U. L stands for lower number, and then 5 is upper number. Okay? So things like that. And then sa horizontal axis, yung XL is actually your 213.57, ano? Or yan yung moment ng 0.4. Tapos yung X sub U, yan yung VMN ng 0.5. Okay? Tapos yung Y sub U, that is the VPN ng 0.5, which is 1923. And then Y sub L, this is the VPN of 0.4, which is 27.66. Okay, so remember those. And then, let's take this as tan theta. Okay, so tangent of theta is equal to YU all over XU. So from there, you can simply determine your theta. Okay? Next is, i-plot natin yung ating eccentricity E. Ayan. Which is 0.13. Remember that slope, okay, tangent of phi, ito yung ating phi, yan, okay, so tangent of phi is equal to 1 all over E. Okay, so yung E natin is 0.13, okay? From there, you can determine now your phi. And then, let us now solve for your interior angle beta. Let's take this as interior angle beta, okay? So, from there, your interior angle beta is equal to phi minus theta. Okay? And then, if this is angle theta, then this also must be angle theta. Okay? Yan. That is angle theta. And then, let us solve this angle. Let's take this angle as angle delta. Okay? So, tangent of delta is opposite all over adjacent. And that opposite is simply equal to YL minus YU. And then the adjacent is XU minus XL. So, you can now determine your angle delta. And then, from there, and then let's take this combined angle as angle alpha, okay, or letter A. So, angle A is equal to theta plus delta. And then, if this is angle A, sabihin na natin na itong side na yan nung triangle, let's take this as side A. Okay? Side A. And then, next, let's take this side as small c. Okay? Let's take this side as c. So, c is equal to the square root of x u squared plus y u squared. Okay, so from there you can get your C. And then, kunin natin tong angle na yan. And that interior angle, let's say, is angle C. So angle C now would be simply equal to 180 minus angle B minus angle A. Okay? Next, by sine law, we can now solve for side A. So A over sine of angle A is equal to small c over sine of capital C. So, meron na tayong angle A, ayan. Meron na tayong small c, which is this. Tapos meron na tayong angle C, which is this. So, you can now solve for side A. Okay? Next is, punta na tayo sa triangle. Let's take this point as y, okay? Let's take this as y, which is basically your yan ang ating kailangan, ano? So, sine of phi. Remember that sine of phi is equal to y, ito, all over the hypotenuse A. But what is phi? Na-solve na natin yan, no? Yan yung angle nung line A. Okay? So from there, you can simply solve for y. So ito yung aking solution. Pinasok ko na siya sa Excel. Ito yung kanyang equations, ano? So yung ating E ay 0.13, which is greater than E4 na 0.077 and less than 0.148 na E5. Kaya we will use range 5, no? Which is, ito yung range 5. Next, yung ating XU or X up would be ito, XU 284, ayan. Tapos XL is ito 213.57, ayan. Likewise, yung ating Y, okay, Y up is 1923, ito. Take note that U or up is the higher number. Okay? YU, ito. YU 1923. And then Y law is 2766. Ito siya. Next is, we apply these equations. So, C is equal to XU square plus YU square. XU tsaka yung YU would give you 1944.19. Next, yung theta naman, that is equal to shift tangent YU all over XU. Okay? Ayan, pinalitan ko na. YU, YL, XU, XL. And then, phi is equal to shift tangent 1 all over 0.13. Ayan, ano? Which gives you 82.56 degrees. And then, yung delta naman, which is ito, no? Delta is equal to shift tangent YL minus YU all over XU minus XL. And then, A is theta plus delta. Okay? So, theta plus delta will give you angle A. And then, angle B is equal to phi minus theta, which gives you point 98 degrees. So, very small, ano? And then, angle C is equal to 180 minus beta minus angle alpha or angle A. Next is side A. Side A is equal to side C times sine alpha all over sine C. Ayan, sine law yan, ano? And then, from there, this becomes a simple right triangle. Your y now, which is your required P sub n Bresler equation, is sine of phi multiplied by A. Yan. Okay? So, I can send you a screenshot of this. Ito yung mga equations. Pagilid ko lang yan. Tapos, yung sa given naman, sa sample, ito yung kanyang mga na-solve, ano? So, E is 0.13, ayun. Tapos, Y sub U, Y sub L, X sub U, X sub L, small c, ito, 1944, which is this. Tapos, theta, phi, and then delta. Yung angle delta, ito yun. Tapos, yung angle capital C, 12 degrees, which is this. And then, yung PN, or capital Y, ito yung ating required, ito yun. Okay? So, that is your required here, 2079.55. Yan ay para dito. Okay, so for this given, ito yung ating sample. Yan ang kailangan natin. Okay, so going back to our figure na 400 by 500, tapos yung kanyang PU ay 982.07, tapos MUX is 128.32. So, na-solve natin yung Bresler PN. This is 2079.55 or 2079.6. Yan yung PNX. But, what if meron tayong MUY, okay? So, next. So, maglagay tayo ng value na MUY, which is equal to 206.57. Our MY is 206.57, ano? Kilonewton meter. And, ang mangyayari niyan, ang ating B would be 500, tapos H would be 400. Okay? Tapos, ayan, 206.57. You have the same PU, 282.07. So, step 1 would be determine your E. Okay? So, lumalabas na ang E mo ay 0.21 and hanapin mo yung E 0.21. So, it is between 0.6 and 0.7. Okay? Yan. It is 0.6 and 0.7. Kaya, nandun ka sa range 7. Ngayon, ang gagawin mo, ang gagawin natin ngayon is, since range 7 siya, yung lower, yan yung magiging 0.6. Tapos yung upper, yan yung magiging 0.7. Okay? Y sub U now would be 601.796. And then Y sub L would be 1219. Okay? Tapos, X sub L would be 236, tapos X sub U would be 267. Okay, from there, you can proceed to solving your small c, theta, phi, delta, and then angle A, angle B, angle C, side A, and then finally your Bresler Pn. Ito ngayon yung magiging Pny. Okay, so from this MUY, lumalabas na ang ating PNY would be 1143.9. By the way, this is already phi. Okay, so this is already phi PNX, and then this is already phi PNY. Okay, yan. So we can substitute this directly here. Okay, so ang ating phi PN now would be 1 all over phi PNX 2079.55 plus 1 all over 1143.9 0.91. Okay, and then minus 1 all over phi PO. But ang gagamitin nating phi is 0.65. So that is 0.65 multiplied by PO na 6231.02. Okay, so yan ang ating gagamitin. Next, our demand over capacity ratio would be PU all over phi PN. This should be less than or equal to 1. Ayan. So, lumalabas na ang ating phi PN is 902.39 kilonewton. So, next, let us compute your demand all over capacity ratio. Yung 902.39, yan yung capacity using biaxial moments. Ibig sabihin, dalawa, MUX at MUY. Ano? So, your demand is your PU 982.07 divided by capacity VPN 902.39 will give you 1.08. As I've said before, your demand capacity ratio should be less than or equal to 1. But in this case, it is greater than 1. Therefore, it is fail. Okay? So that's it, guys. Get ready for your next quiz. Thank you, guys.